Next, we're going to talk about exponents, roots, and order of operations. So, friendly reminder that an exponent is a whole number, right, that indicates how many times a base number is to be used as a factor. Like I said, multiple mathematicians are lazy, so we needed better notation. If I'm going to multiply 8 by itself 3 times, I could just write 8 to the third, okay? And this especially comes in handy when we have like 10 to the 15th or 7 to the 16th. Those are going to be really big numbers that you wouldn't want to write out anyway. Also, friendly reminder, our whole numbers are 0, 1, 2, 3, ... So those are exponents. Any number other than 0 raised to the 0 power is 1. Okay? So if I have 7 to the 0, that's 1. If I have 8 to the 0, that's 1. Note that any number raised to the first power is just itself. 7 to the first power is 7. 6 to the first power is 6. Okay? That's just kind of saying 6 multiplied by itself once. It's important to note that 0 to the 0 power is undefined. That's something you're just going to have to memorize. Here's a few examples of exponents. I have 9 squared, 2 cubed, 5 to the first power, 3 to the fourth, and 9 to the 0 power. Okay, that's how I'm going to say them out loud in class. So to help you with your note taking, it's good to know the way those are said. Exponents can be used to square a number, right? And square roots undo exponents. So it takes us from the square of a number back to itself. So if 3 squared is 9, then the square root of 9 is 3. They undo each other. Oops. So if we want to take 5 squared, we'd take 5 times itself, and we'd get 25. Now, the square root of 25 is 5, okay? We are undoing what we did before. We call this symbol right here, this is a radical sign. The whole thing itself is a radical. So this is an example of a radical. 25 is the radicand, right? That's what we are taking the square root of. It's important to note that for this square root, it has an index of 2. And that makes sense, right? We squared, we're taking the square root. It has an index of 2. And we don't write that number right there. But say if we were taking the cube root of 8, right? Because 2 cubed is 8, so the cube root of 8 is 2. This would have an index of 3, and we would include it in our radical symbol. It's also important to note that when we're working with square roots, that every number has a positive and a negative square root. Because negative 5 times negative 5 is 25, so the square root of 25 could be negative 5 or positive 5. Now, typically, we're always going to be asking for the principal square root or the positive square root. If I have a negative symbol in front of my square root, that's when I want my negative square root. So if I asked you for the negative square root of 16, well, 16 is 4 squared, so that would be negative 4. Let's do some examples. The square root of 16 is 4. If I ask for the negative square root of 36, I simplify the square root of 36, right? That gives me negative 6. The square root of 25 is 5, as I said a bunch on the previous slide. And the negative square root of 81 is going to be negative 9. It's important to note that square roots of any number that is not a perfect square is an irrational number. So let's talk about the first few perfect squares. Well, I've got 1 squared, which is 1. 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, and 7 squared, which is 49. I would recommend knowing all the way up to 9 squared, which is 81, right? These are perfect squares. So they're going to have rational square roots. if it isn't a perfect square, it's going to have an irrational number square root. Remember, irrational means the decimals go on and on forever. It cannot be written as a fraction. So an example, that would be the square root of 5 or the square root of any prime. That's always going to be irrational.